Hey, good morning, pre-calc. And today we're going to kind of look a little bit at how to graph this library of functions. So last year in Algebra 2, you guys had some of these terms or some of these functions. Some of you maybe took it at a different school though, so I'll catch up on all of them. If we look here, our first one, f of x equals x. Okay, and remember f of x is the same as just like y equals x. Okay, it's just the function with respect to x. It's just a different way of writing that. So f of x equals x, and the name of this function is going to be linear. Okay, so it's simply just a line. Now, to graph all of these this first time at least, we're going to make a t-table. Okay, so t-chart or t-table for our x and our y, or actually instead of y, that is our f of x. Meaning, if I plug in, for example, a 0 in for x, if I plug that in right here for that x, 0 will be my answer. If I plug in a 1, I'm going to get 1. 2, a 2. A negative 1, I still get a negative 1. Whatever I plug in, I get the same thing out. Okay. Now, we put a few points on there then, and since this is a line, it goes right through that, and this function, this parent function, is just linear. Okay, so our next one, x squared. Okay, hopefully you guys know this one. This is a quadratic. Okay, and the shape that it forms is our parabola. Now, some of you guys might already have this one memorized, which if you do, that's fine. You can graph it. If not, we want to once again form our t-table with x and f of x. And we'll start by plugging in a 0 here. 0 squared still gives me 0. If I put a 1 in, 1 squared gives me 1. Negative 1 squared also gives me 1. Okay, 2 squared gives me 4. Negative 2 squared also gives me 4. 3 squared gives me 9. Negative 3 squared also gives me 9. Okay, and some of you guys might know the 1-3-5 rule. If you know what I'm talking about, you can use that when graphing parabolas. If you don't know what I'm talking about, don't worry about it. We don't have to use that. So we put these in, and then one thing that's important that some of you forget when you're graphing parabolas, don't forget to draw in your lines, put an arrow on the end because it keeps going. Draw on the line, put an arrow on the end, and that is our quadratic. Okay, that's the parent function, is called the quadratic. It's when we have an x squared. Okay, our next one, x cubed, and this is what we call a cubic. Okay, now the shape for this one is a little harder. Some of you maybe think of it as like a stretched S. If you don't want to put anything, you don't have to. This shape does not really have a name for us, but our cubic, once again, let's start with x and f of x. And 0 is always a good one to plug in first. So if we plug in 0, 0 cubed is still 0. Okay. If I plug in a 1, 1 cubed, 1 times 1 times 1, still gives me 1. And negative 1 times negative 1 gives us positive 1, times another negative 1 goes back to negative. Now if I plug in a 2, 2 times 2 is 4, times another 2 gives us 8. Negative 2, likewise, will give us negative 8. And then we draw that. Oops. Let me redo that line. There we go. And that is our parent function of the cubic. Okay. Now, hopefully you notice it was an odd function, so it's symmetric over the origin. Okay. That is the case also on this one, it's not an odd function. This one is an even function, so it's symmetric over the y-axis. The first one was an odd function, symmetric on the origin. Okay. Now this next one, on this one, we have the absolute value. Okay, so the absolute value, and because of the absolute value, we actually can't use our even or odd rules, but our absolute value, I'm guessing lots of you know this one. It's going to make a V shape, and if we think about it, x and f of x, if I plug in a 0, I still get a 0. If I plug in a 1, absolute value just means what is the distance from 0. So that's still 1. Negative 1 is positive 1. All of them are going to be positive, whatever we get. It always comes out positive because absolute value has to be a positive answer if it's the parent function. So that would continue kind of like a straight line. Also goes this way. And we are done with that parent function. The absolute value looks like a v. Okay. Now, we've got two more. This next one, square root. You guys have seen this one. Last year we did it also. And the square root, it is kind of doesn't really have a good name for the shape. So just remember it always goes to the right, okay, and then it kind of arcs up. The slope levels off. So if we start with our x and our f of x, once again our t-table, and the reason these t-tables are useful is anytime you need to, you can always just make a t-table, plug things in, and figure it out. So if I would put in a 0 for x, the square root of 0 is 0. If I put in a 1, square root of 1 gives us 1. If I put in a 4, square root of 4 gives us 2. I'm choosing numbers that are nice to go in here. I could put like square root of 2, but that's going to be like 1.32 something, and that's not very nice to graph. So instead, we're choosing the numbers that we put in. Make it easier on yourself. And 9 is a perfect square, so I'll plug that in. Square root of 9 gives us 3. Now, if I put in a negative 1, square root of negative 1, if you do that on a calculator, it's going to give you an error. Remember, that would be an imaginary number, and we are not going to deal with those in this chapter. We can't graph it. Okay, we can only deal with the ones that are positive for a square root. So 0, 0 is right here, 1, 1, 4, 2, and then 9, 3, and it arcs over, and it has an arrow there. Okay. Now our final one, this one is a little bit unique. You probably didn't see this last year in Algebra 2. I know I did not teach it to my Algebra 2 students. So this is called a reciprocal function. Okay, so our reciprocal function, and I'm going to put here, it's kind of like a double boomerang. So our double boomerang here, which our double boomerang, and what I mean by that is it kind of is going to look like two boomerangs going in our situation here. So I'll show you quick. If we plug in to our function, we got x, f of x. Now, this one's unique in that we have some values we can't put in here, just like the last one, except in our case, we usually always start with 0. 0, if we plug in 1 over 0, that would be undefined. We can't have that. Okay, so we can't graph the line when x equals 0. So if you want, I'm putting like a dotted line down there. Okay. Now, if we plug in a value of 1, 1 over 1 still gives us 1. Now, 1 over 2, that's going to give us 1/2. 1 over 3, 1/3, 1/4. It keeps getting closer and closer to 0, but it's never quite going to get there. Okay. Now, if I put in like a 1/2, 1 over 1/2 actually gives us 2. Okay, so it's going to go the same way on this one. It gets closer and closer to 0. Now it's a little messy. Now, likewise, if I plug in a -1, 1 over -1 gives me -1. Okay, so it's going to be a mirror in our case, and it's going to go the other way for us. All right, so that's what it should look like. I know my picture is a little messy, so let me pull up here and go to Desmos and show you guys the graph so that it can be a little bit neater. So if we click on this graphing calculator, and then y equals 1 over x, or in our case, so I can keep the same formatting, f of x equals 1 over x, and you see this is what I mean by the double boomerang. Okay, so if you guys have any questions about any of these things, let me know. Today was just kind of our introduction of these. Tomorrow we're going to start moving functions around, transformations, shifting them up, down, left, right, flipping them. So once again, hope you guys have a great day, and see you guys tomorrow.